that if I had e to the natural log of something, I could use the purple rule, but I don't have e to the natural log of something. I'm trying to find the derivative of e to the 3 natural log of something. So the purple rule does not apply.
Is it because of the 3?
Because of the 3. It has to be e to the natural log of whatever. I can't have an extra constant here. Questions? For Brennan? However, I remember the green rule that 3 times the natural log of x squared is going to be the same as natural log of x squared raised to the 3rd power. So this work here in brown is me just working on this piece up here, just the little top. I'm ignoring e for just a moment. Using the green rule, I can get that this is equal to this. Question? Cool. So now, this derivative is equivalent to this derivative. So I'm really not doing any calculus yet, only algebra. Now I can use the purple rule. Derivative of e to the natural log of something is just the something. So this is equal to derivative of x squared. Sorry, x to the 6th. Question? Solid. You don't need me to restate anything. Okay, go to number 32. Make sure you do your work in your note, but please don't do it in the packet. I tend to have a soft heart when people show me work in the packet. I have help, but I'm getting tired of helping when it's in the packet. It's hard to see what you're doing because you're just squishing it in there. Like if you can't, look at me, if you can't afford the paper, come to me, I will buy you paper. And if you're worried about trees, don't worry about it because they planted the trees to make paper out of them. Otherwise, they wouldn't have planted the trees. So, and the children of the farmers who grow the trees will be very sad this Christmas if you don't provide some papers. All right. Okay, so I read the problem. They give me f. That's nothing special. I get that in lots of problems. Then they say something I'm not really expecting. They say G is F inverse. I would say 95% of the time on the AP test, if they start talking about F inverse, there's a good chance they want me to use this formula. So you'll need a flashcard for this. I use 2 as an example. It could be 3 or 7 or 5 or whatever. The derivative of f inverse at x equal 2 is equivalent to 1 over f prime of inverse f inverse of 2. Okay, just a formula. For our class, you don't have to know where the formula comes from.
Where does that line come from?
So the line means at. So it means find the derivative at an x value specifically of 2. Yes, this will need to be on a flashcard. Without this flashcard, you can't solve this problem. So. 2 for Danny, 2 for Hayden. So I keep reading. G of 2 is 1. I'm not really sure why they're giving me these purple clues. So just kind of take note. They want me to find g prime of 2. Now I see the connection. So the derivative of g of x at an x value of 2 is what I'm supposed to find. But because g and f inverse are the same thing, this is the same as finding the derivative of f inverse when x is equal to 2. Questions to there? Awesome.
So you find that inverse, is that what the 1 over f prime of f?
Right, it's perfect. That's why I need the flashcard.
Okay.
So I know that I'm trying to find this. Using the flashcard, that means I'm trying to find this. 1 over f prime of f inverse of 2. 2 points for Allison. No. Okay, these are what I refer to as puzzle problems. They don't have a story, they're just a bunch of symbols. You have to see how the symbols interact with each other. So the first part of the puzzle was, I'm supposed to find g prime of 2. That led me right here and said, oh, finding the derivative of g is the same as finding the derivative of f inverse. So I remembered the flashcard to this junction in the problem. Now I've got to find f inverse of 2. That's this one. So f inverse of 2 is the same thing as g of 2, because f inverse and g are the same. So this is equal to 1. Do you need me to restate anything? Please.
Oh, wait, never mind.
No worries, good point. There we go. Please.
How does it equal 1?
So again, just kind of stringing the puzzle pieces together. G and f inverse are the same thing. So finding g of 2 is the same as finding f inverse of 2. And they told me that g of 2 is 1. Oh, good question. 2 points for me. Anyone else? Awesome. Okay, so putting all these pieces together, I now have this is equal to 1 over f prime of 1. Questions? So hands up if you know the next thing I'm going to do. Just trying to solve the puzzle. So I've got to find f prime of 1. So how do I do that? Okay, everybody on this one? How do I find f prime of 1? Boston.
Find the derivative of fx.
So I come over here and say f of x is equal to x cubed plus x. So f prime of x is 3x squared plus 1. How many knew I was going to do that? Yeah. 2 points. You need to talk more about it. Cool. So f prime of 1 is equal to 4. Now I know over here that the derivative I'm looking for is going to equal 1/4. Do you want me to talk any more about that? So really, you must have this as a flashcard. The rest of it is just your ability to think through the puzzle. So. Cool, next one. Please go to 36. Is just another puzzle. There's no story, you're just putting the puzzle pieces together. I need to find h prime of x if I'm going to find h prime of 1. Hands up if you know what goes here. You think better if you think with me versus watching. So what am I going to write here? I'll pay everybody. Hands up. It says h of x is equal to f of g. I need to find h prime. So hands up. What do I write? Okay, everybody raises their hand and has the correct answer. Let's go, Maddie.
The f prime of g of x. And then times d prime of x.
How many knew that's what we would write? 2 points. If you're having trouble remembering this, do this. The derivative of the cosine, so let's use sine so there's no negative. The derivative of the sine of x squared is equal to the derivative of the sine, which is the cosine, plug back in the x squared, multiplied by the derivative of the x squared. It's the same thing over here. The derivative of f is f prime, plug back in the g, now multiplied by the derivative of the g. Anybody else? Awesome. So now I need to find h prime of x equal 1. So I write that down. H prime of 1 is f prime of g of 1 multiplied by g prime of 1. So I need to find g of 1. Raise your hands, please. What's g of 1? Feel free to talk to each other. We got some dead spots in the room. So. What's g of 1? G of 1, we'll start there. I need both of them, but we'll just go left to right. So I need g of 1. So, Trey?
Just -1.
So we go to x equal 1. G of 1, definitely -1. How many knew it? 2 points. So this becomes f prime of -1. Now we need g prime of 1. Hands up. What's g prime of 1? Go Weston.
That's 2.
So g prime of 1 is 2. How many knew it? 2 points. Now I need f prime of -1. And Isaac?
5. So
let's see here. F prime of -1. Perfect is 5. So how many knew it? 2 points. So we have 5 multiplied by 2. The correct answer is 10. Question. Just another puzzle, so awesome. Turn to 44, please. Okay, remember the goal here is to get you to where you can think through the problem. Copying doesn't do any good. I sarcastically said last period, but it's not, it's an accurate statement. I said the reason you earn $12 an hour to work at a fast food place is because it doesn't take hardly any time at all to train you. It really doesn't take very much to train a new person. So you're only worth $12 an hour. If you want to earn 40, 50, 60 bucks an hour, like in a profession, you have to be able to think on your own. Okay, like this. It's a really simple example of thinking on your own through complex situations. So when I read the problem, it says C and D are constants. F is differentiable at x equal 2. What is the value of C and D? I'm reminded of a flashcard which says, if looking for something like C and D, don't. Do a bunch of other stuff, you'll just find C and D. So I'm drawn to the fact that this function is differentiable at x equal 2. As soon as I read that, I immediately think of a related idea. Raise your hand if you can read my mind. What am I thinking? When I read that f is differentiable at x equal 2, I immediately am reminded of a flashcard. What am I reminded of? Mikhail.
What, the non-differentiable flashcarding?
For sure. So I come over here and think, okay, what's the differential? So f is differentiable. And what I'm thinking of is first continuous, then no corners. Let's see, corners kind of like that, and no vertical tangents. Actually, on a graph, a corner doesn't usually look like that, so let's draw it different. Corners are this kind of thing. I'm having a hard time with corners today. We'll just go with that. And no vertical tangents. 2 for Mikkel. For a function to be continuous, because I have to check that first, that reminds me of another flashcard. Hands up. Sarah?
Find the limits of 2.
So I need to find the limit. So f is continuous at x equal 2 if the limit as x approaches 2 from the left is the same as the value of the function at 2 is the same as the limit as x approaches 2 from the right. Please raise your hand if you were thinking I would write what I just wrote. Show me that. 2 points. Okay. If you're not, these things aren't coming to mind, it's because, like, eyes on me, everybody, eyes on me. It's really simple. I talked to a father on the phone. He's the father of one of my students. This particular student is not doing well in this class. Okay, he's D- for the first term, D- for the second term so far. Okay. The dad understood. You know why? Because the dad took calculus in college. And his recollection was, oh, I remember when I took calculus, it was like I had to work on it for several hours. I had to go to the math lab. I had to get help. It took a lot of effort. It was not a simple, passive, kind of show up, pretend class. He said, I don't see my son doing that, so I can see why he's not doing well. It is really a very simple recipe. So if we do this and your brain is just drawing blanks, because you haven't done anything to prime your brain. Like you haven't spent any time with the flashcards. Like if you don't do the effort, it won't work. Okay, you've got to do that yourself. I cannot memorize things for you. Okay. Anyway, so hands up if you know what goes here. What am I going to write? Talk to each other. So hands up, what goes here? More hands, come on. What goes here? Let's go, Grant.
2 times c plus d.
Well done. So the value of x is a little bit less than 2, so I have to use the top. C and d I don't know, but I know that if x is close to 2, the y value is going to be pretty much 2c plus d. How many knew it before I wrote it? 2 points. Hands up, what's f of 2? Think with me, don't just watch. What's f of 2? Anna Kate?
2c plus d.
How many knew it? 2 more. This one? Go. Think through it, come on. What's the limit as x approaches 2 from the right? Let's go Hadley.
2 squared minus 2c.
We've got 2 squared. Subtract 2 times c, or 4 subtract 2c. How many knew it before I wrote it? 2 more. Question. I mean, you need to restate anything, talk about anything. It's like most AP problems. I'm not trying to solve the whole thing by knowing ahead of time what to do. I remembered one thing, That memory led to another memory. Did this, leads to another memory. So the function is continuous as long as these three are equal. So that means that 2c plus d must equal 4 subtract 2c. That's a bit of a dead end. One equation with two unknowns can't be solved. So because f has to be differentiable, I know f has to be continuous. If f is continuous, these three must all be the same. So 2c plus d has to be the same as 4 minus 2c. Points? Can't solve one equation with two unknowns, so I got to do something else. Please, Brendan.
You just divide 4 minus 2c divided by 2.
I can divide the 2 for sure. It just won't help anything because with c and d both being unknown, you can rearrange all day long. You'll never find them. So I'm just going to leave that for now. 2 points for Brendan. Hadley?
Could you just stick like a random number to D and then try and find something to make it all equal?
Very, very
It's gonna take
difficult.
too long.
Yeah, you're right. You can try that, but it's going to take a long, long time.
Can you do like the thing you used to do in like 7th grade where you line them up on top of each other and you know 2c minus 2c 0 so d plus 4 so d minus 4.
What you remember doing is actually having two separate equations, not one equation.
Oh, it's one equation.
Yeah, so you can't do that.
Could you do, like, so could you rearrange it so you just have d on one side and then it's the 4 minus 4c and then you plug in the value for d so you can find what c is and you go plug that back in.
Yeah, if you know the value for d.
Well, d doesn't, I mean like the equation or whatever, like after you rearranged it.
Hold on a minute. So all the suggestions you're making, like this is legal. It is legal to rearrange to get this. Is that what you meant?
Yeah.
Now what do you want to do?
Could you go to like the previous thing like and plug the like 4 minus 4c in for d instead? And
Oh, like you want to take this and plug it in up here?
Yeah.
Gotcha. Everybody eyes up on the board. Everybody look. 2 for Danny. Everybody. Okay, if you take one equation, rearrange it like that, and then substitute back into the other equation you started with, you're always going to get 0 equals 0. Like it will be true, but it won't help you find anything. So one equation, 2 unknowns, dead end. You have to have something else. So this is fruitless, and like Hadley said, we can guess and check all day long. Not a good strategy on the AP test. You just burn up time. You don't get anywhere. I'm going to keep going this way. I know the function is continuous if this is true. To be differentiable, I can't have corners or vertical tangents. To check for that, I need the derivative. So I come up here and find the derivative. So f prime. We did something very much like this last class period. So hands up if you know what gets written here. Show me your hands.
I have a question.
Hey, please help.
Why are you doing that right now?
Keep going a little bit further, it'll be easier to see. Yeah, once we get a little further, it's easier to see why. Good question, Hadley. 2 points. So what goes here? Don't overthink it. A piecewise function simply means 2 formulas. This half of the function uses one formula, this half uses the other. So the derivative is just the same idea. So what goes here? Just c. Cx plus d is like saying 3x plus 5. The derivative of 3x plus 5 would just be 3. So the derivative of cx plus d is simply c. Somebody knew it before I wrote it. 2 points. You want me to talk more about it? Please.
Can you do that again?
Huh? Are you comfortable that the derivative of 3x plus 5 would be 3?
Yeah.
Okay? So it's the same thing here. You just don't know that c is you don't know what number c is, but it is some number. So if this said 4x plus 7, this would say 4. And did that answer your question?
Yeah.
2 points. Anything else? Cool. What do I write here? Show me your hand. Come on. Chase?
2x minus c.
Somebody knew it? Two more? Okay, caution. Just because a formula piecewise says equal to here and not equal to here, doesn't mean you can put an equal sign here. So don't just automatically put the equal sign. If the function has a corner or vertical tangent at x equal 2, then I cannot put the equal sign. You need me to restate? Anyone need me to restate that? So here's f. We know f is continuous. F will only be differentiable if there are no corners or vertical tangents in f. I know there are no vertical tangents. Who knows why I know that? But think with me. How do I know that there are no vertical tangents, Drew?
It's a piecewise function, and yeah, and the slot.
You're okay. 2 points. Somebody help. Noah?
There's no number of the denominator.
Right. For a vertical tangent, the derivative's got to end up equaling, like back up here, so like an f prime of 2, that's the point we're interested in. If there were a vertical tangent at x equal 2, f prime of 2 would end up being a number divided by 0. But neither of these formulas can become a number divided by 0. How many knew this? 2 more. Corner I could still have. Okay, any questions?
So now, why are you checking all these when it says that it is differentiable, and if it is differentiable, it can't have that? Does that make sense?
It does make sense. 2 points. For this particular problem, you are correct. We actually don't need to check it. I just thought it'd be a good chance to review.
Oh, okay.
Perfect. Please.
So does that mean that in order for it to have a vertical tangent, it has to have x?
In the denominator.
Okay, not just like a number other than
Right, because like
x.
over 5 or something, still not going to ever make the denominator
something that
0.
you can make it 0. Okay.
Correct. So if f prime looked like this, Brennan. Now when x is equal to 2, the value of the derivative will be 3 over 0 vertical
It's not
tangent.
differentiable.
Yeah, not differentiable. As Danny said, that was just reviewing an idea. They told us that f is differentiable, so we're safe to put the equal sign. If f is not differentiable at x equal 2, don't put the equal sign. Please.
Wait, but we know f is differentiable, but we don't know that f prime is, so can we still put it?
So, yes. If f is differentiable, then the values of f prime can all be found, so there will be an equal sign there.
Okay.
2 points. Okay. You need to have this flashcard. I gave it to you last time. F is differentiable at x equal 2 if the limit as x approaches 2 from the left of f prime is equal to the limit as x, no, not the limit, sorry, the value of f prime at 2 is equal to the limit as x approaches 2 from the right of f prime. That was a flashcard we did last time. So raise your hand if you know what I'm going to write here. There we go. So what's the limit as x approaches 2 from the left of f prime? What does it say?
C.
C. How many knew it? 2 points. What's f prime of 2, Hand? Cambry? How many knew it? Point. What's the limit as x approaches 2 from the right of f prime?
4 minus
What is it, Hadley?
4 minus c.
How many knew it? 2 more. So these must be equal now. That is one equation with one unknown. That can be solved. Once you know C, you can come back over here and find D. 4 times 2 is 8. So D is equal to -4. C plus D is -2. Question. So this problem contained no new concepts. It was a matter of just applying what you already knew to a new situation.
Okay, so where did you get the idea to do that prime? Like, you're really sitting in the...
No, you're awesome. You asked that earlier. So, you're okay why I thought of this?
Yeah.
Okay. To check to see if a function is differentiable, if I don't have a picture, I have to have f prime. And then once I have f prime, I do this test to make sure that the function is differentiable. So that's what led me to find f prime. Did that help? Kind of. Maybe think of it this way might help, Hadley. I can't really test to see if f is continuous unless I have f itself. I can't test to see if f is differentiable unless I have f prime. Unless I have a picture, then I can take a different approach. That seemed to feel a little better.
So you did like the very left of that was to find the continuous cosine. Then we knew it wasn't vertical tangent because it wasn't any denominator. But then when you check the corner, that's that one.
Correct.
Okay.
Perfect. This will check for the vertical tangent as well, to be honest. You'd find it doing this as well.
Okay.
But vertical tangent's a little quicker to recognize just by that. So, please, Mikhail.
But don't we already know there's no vertical asymptote tangent because it said it is differential?
Correct. So what I'm doing is the same. So it goes back to the flashcard that said, hey, when they ask me to find C plus D, I'm not going to really worry about C and D. I'm going to do things that I would normally do on a problem that's similar and just hope that I can find C and D. So even though I know that there's no need to check for corners, there aren't any, by checking for the corners is how I figure out the value of C. That's 2 points. Anyone else?
How long do you have on each question? Like, would you think would be this?
That's a tough thing to answer because every question is a different amount of difficulty. I can tell you this. I've never ever had a student in 11 years come back and complain about how much time they have. And I've had some students who were very worried about it. They're like, I just take a long time to do
Yeah,
things.
because this like takes a long time. I guess it's not if you're going fast.
My experience is you don't want to go fast on the AP test. It's not like the ACT. The ACT is a race. You have to go fast to get a good score. The AP test, you don't. It's much better to do a certain number of problems methodically and just step by step and carefully. You'll do far better than if you try to hurry. The AP test is not, okay, I'm giving you old AP questions on the test you take, but I'm only giving you like a sample of all the questions you're going to have to answer. Once we start doing a full AP test, the goal changes. Like I've been telling you that, you know, like the last test I said, if you got 79 or above, you're in good shape to move on. If not, you need to retake. The AP test, if you get 66%, typically, it'll vary a little from year to year, that's a 5. Okay? You do not have to go fast. So I don't ever worry about the time. Like we will practice the timing so you get used to it, but you don't need to worry about it. So. questions? Awesome. Okay. We have a little bit of time for those who actually got through the homework and they walked around. There were several people who said, yeah, I got through most of the homework, had about 3 or 4 questions. What specific questions did you have, Lindsay?
24.
Anyone else?
10 and 12. It was like the same as
So we probably won't do both. Anybody else? Please. Anyone else?
This wouldn't be first priority, but 19, but it was this kind of the same concept as 16. So I feel like I should be fine.
Oh, I see you, because we went over the other one. I got you. 10 and 12 are basically the same problem. 10 is a little more difficult. So we'll do, 12 is a little more difficult. So we'll do 12 together, and then you can verify that you're understanding by doing 10 on your own. Like, hey, I think you all know, but it does no good if I just do all the problems for you. Usually does. Okay. So let's talk about 12 together. Again, hey, don't think that when you read a problem, you're supposed to immediately recall, oh, step 1, step 2, step 3, step 4. If you watch me model how I solve the problem, pretty rare that I would ever say, here's step 1, step 2, step 3. I simply find one thing to write down, and then I use that to remember something else. So they're talking about the mean value theorem, so I remember the flashcard. Mean value theorem means secant slope equals tangent slope. Mean value theorem means secant equals tangent, or average rate of change equals instantaneous rate of change. So I've got a function. So that's my formula for finding every xy pair on that curve. They tell me the interval starts at x equals 0. They don't tell me the y value. Stops at x equals 2. I remember, if I'm trying to satisfy the mean value theorem, I want to find where the where the tangent matches the secant. That's where you start. So now you should be thinking what I'm thinking. So raise your hand. What am I thinking? I'm trying to connect the dots. Danny?
So don't we plug in the x value so we can find the y value so we can secant slope?
Nicely done. It's perfect. So I come over here and say, let's go find f of 0. So that's 0. So this point starts at 0, 0. Now we're going to find f of 2. Also, it's a minus, isn't it? Sorry. Mistake. Also 0. So now I know that.
It's 2x4.
Oh man, alive. There we go. How many thought what I thought? Come on. 2 points. They want me to talk about it. Please.
When you do problems like this and you find the secant, like Like if you think now you know it's 0, 0 and it's 2, 0, does it matter? Like should you think, oh, it's flat, so then like that has to, there's only one like option for doing parallel, do you know what I mean? Or do you just like use the numbers?
Just use the numbers. No, it's a good question, Brennan.
Like if you can see that it doesn't even move over X, it just goes up and down. Like, do you know what I'm talking about?
Yeah, you don't really know what F looks like though. F could do this, all kinds of
So
things.
just because we saw like that it didn't move up and down on the Y doesn't like mean anything.
Not really. We do know that the secant slope is horizontal,
Yeah.
but we don't, without more effort, we don't know what the graph of F actually looks like.
Because it could like.
So here's different possibilities. F could look like this. F could look like this.
And so we wouldn't know exactly which point, right?
No, F could look like that. So I don't pay attention to the appearance of F because I don't know it. I just use the numbers. Is that what you meant?
Yeah.
It's 2 points. Anybody else? Please, get
So
going.
then do you just find the derivative of x?
Nice. So derivative F.
Of f, yeah, not f.
So, no worries. So I come over here and say, so what Brendan was talking about is that we did figure out that because one point is 0, 0, and the other point is 2, 0, the y value isn't changing. So the secant slope must be 0. Secant slope is equal to change in y divided by change in x. So whatever the graph looks like, we'll just pretend it's that. The secant slope from one end to the other is 0. Okay, 2 points from Mikkel. Please raise your hand if you know, why did she say I should find the derivative? Like, why? You must learn to, you must learn that in college level classes you're going to have to know the why for anything that has any challenge at all. I mean, there's a few easy ones like religion at BYU, but I didn't say that. Okay, it's true, that was always an easy class compared to this stuff. Okay, that was relaxing. I was like, oh, I'm just going to relax a little bit and go take differential equations. Okay, yeah, but for everything else, you got to know the why. You can't succeed without knowing it. So why are we taking the derivative? Okay. Right. The derivative is the formula I use to find the tangent slope. So f prime is going to equal 3x squared minus 4x. How many knew that's why we were taking the derivative? 2 more. What do I do with the derivative now that I have the derivative formula, Rachel?
And I find f prime of 0.
So 2 points for Rachel. This is a mistake, and I want to make sure everyone can see why, though. So we really don't want to do what I'm doing. But again, we need to know why, otherwise it's hard to remember. So why is this incorrect? It's no big deal, but just, yeah, please, Rachel.
Is it because, well, this is what my question was on the problem.
You're good.
Is it because the interval is 0 to 2, so you don't want to find it at 0?
So the interval starts at x equals 0, goes to x equals 2. If we finish this thought, we get this. Rachel, what does that mean?
That means that the tangent slope at 0 is 0.
Perfect.
So you don't want to find that because that's not really on.
Yeah, it's not what we're looking for.
Okay.
Does tell me a little bit more like what Brandon was saying about what this thing looks like. Apparently it looks more like this kind of a thing. I don't know. Like right here, the tangent slope is 0. But we're not interested in finding the tangent slope here. What are we trying to find? Okay, Cameron.
You're finding a certain point along the tangent slope where it equals 0.
Right. Some point along the curve where the tangent is 0. So this, really, look out, come on. You've got to keep it straight because in different problems you're going to have to do it both ways. This you will do in other problems, for sure. This is like say, hey, take the derivative formula and find what the slope is on f at some point. That will be required in many problems. But in this particular problem, we're doing something different. So what do I write over here instead, Cambria?
You do 0 equals 3x squared minus 4.
Here I'm trying to figure out what x will cause a slope of 0. This is find the slope for a specific x. This is find the x for a specific slope. You need me to talk about the difference. You have to know both of them. You'll use them in different problems. So, okay, another flashcard that you already have in your deck. Solving an equation means find the value of x which makes the equation true. This is a quadratic. You don't isolate x. You make sure the equation is set to equal to 0, and then you factor. That's one of your flashcards. Okay, you should learn to solve some equations just by looking, because it shows you understand what's going on versus just knowing how to manipulate. So what's one easy value of x which will make this true? Hands up. Just by looking at it, I can say right away, oh yeah, I can see a certain value of x which will make this a true statement, Drew.
0.
How many knew it? Point. Okay, 0 will not be the solution, however, because 0 is at one of the endpoints. No function is differentiable at an endpoint, because differentiable means secant to the right, secant to the left, and you can't go left. So 0 can't be a solution, even though 0 is correct here. That means 3x minus 4 has to equal 0. So at an x coordinate of 4/3, so this point right here, where the tangent slope matches the secant, that's an x value of 4/3. I can talk about this as much as you would like to make sure you're feeling good about it. Please, hey.
So why did you just only do the parentheses?
Smart. So right here, I notice that I have this factor multiplied by this factor. When two factors multiply and the result is 0, okay, what do you know about the two factors? You have two things multiplied, the answer is 0. What do you know about these two things? They have to equal 0. So either x is 0, which we can test it. You put a 0 here. Tell me, what does this become here? This would still be 0. 0 times negative 4 is 0. So it's definitely a solution that x can equal 0. Not the solution we're looking for, because that's at one of the endpoints. So I do this one, say, let's make this 0. So if you put a 4/3 here, okay, what's 3 multiplied by 4/3? So like this, 3 over 1, 4 over 3. 12 over 3 is 4. 4 minus 4 is 0. 0 times 4/3 would be 0, so this is the other solution. Does that answer your question? Yeah, 2 points. Please,
So
Sarah.
the mean value theorem, you can never do it at one of the points, whatever.
The mean value theorem is never satisfied in an endpoint,
Okay, so that's
because it's not differentiable at the end.
So that's the only way you know. You just gotta remember that.
You do have to memorize that.
Okay.
Good question. You could deduce from the answers that they show 0, they show 4/3. Well, this one I know works. There'll never be 2 correct answers, but best to remember that function is not differentiable at an endpoint. The mean value theorem is only satisfied if the function is both continuous and differentiable. Please.
So when we got to that point where we were trying to figure out like what the x would be for it to be 0, like, is it okay if we just look at the answers and just plug it in? If it's I could look at, I could say, is it 0? No. is it one, like, no, you know what I mean?
Gotcha.
Because my brain didn't really, like, go to 4/3.
I understand.
Yeah.
Okay, 2 points for Brennan. I'll give points to the rest of the room. Why is my answer don't do that? Like, why is my answer don't go, it's not wrong, but why would I say don't go plug these in? What's my reason? Hands up. Like, why is that a bad idea? Weston?
Time.
Time's a good answer. 2 points. What's another reason why it's a bad idea? Kev?
On the written portion?
Written portion. Yeah, in the written section, you don't have any answers to check. So to me, best to do multiple choice as much like written as you can. Then you're well prepared for bold.
I have a question. So on 10, it gives like all the other answer it gives have an endpoint. So could you just know that the answer is? Does that make sense?
Hold on, let me look at the same time. 10, very similar, right? They give us a function, they give us an interval, they say where is the mean value theorem satisfied. Well, that's really smart. Can be 0, that's an endpoint. Can be 3, that's an endpoint. Very smart. Very smart. Very smart. That's really smart. Good job.
You know how to do it.
Well done. That's really well done. I've never thought of that. No, I really haven't. 12 years of doing this, I've never thought of that. I would do it on your own, just to get some practice, like in the written section. You know what I'm saying? But no, very smart. Anybody else? Cool. 2 is mean value theorem as well, correct? So I'm gonna let you practice that one at home. 1924. Uh, 19 uses the stuff I showed you from 16. So I'll let you try that one on your own. 24. So we know that H is f of g. Supposed to find H double prime, so you have to find H prime first. Somebody tell me what H prime is. Please, Elijah.
F prime g of x, g prime of x.
That's just like the chain rule.
Chain rule, just by itself. 2 points for Elijah. So now we have to find H double prime. Somebody else? Go, Henry.
G prime x times the derivative of f prime g of x.
2 points for Cambry. Somebody else jump in.
Plus,
Oh, go, please, Matt.
plus f prime g of x times the derivative of g prime of x.
Points for Maddie.
Wait, it's a derivative of g prime.
Ah,
Sorry.
shoot. That would be G double prime. There we go.
Yep.
I'll cheat. Okay, anyone want to talk about any part of that? Like, you can ask anything you want, like, how did I know? How do I remember?
What do you do from this second to the third step?
So from here to here,
Yeah.
product rule.
Okay, yeah.
This is multiplied by this. Does that make sense, Brennan? 2 points.
So why is that that one, that g double prime at the
So I
end?
take the second function.
Yeah.
Just say stop if it doesn't click. Take the second function, multiply by derivative of the first.
Oh, so you just put double prime there and then you put derivative there.
Yeah, it's because I forgot.
Oh, just because you, okay, I was like.
I was lazy.
So they're the same thing, right?
They are the same. That was just laziness. Hold on. Points for Brennan. What's the next line? Go, Elijah.
G prime of x, f double prime of g of x, g prime of x.
That was a nice recovery. Two for Elijah. Someone else? Go, Cameron.
Plus f prime of g of x, and then g double prime of
Two for Cambry. Now I kind of need to look at what I wrote versus the answers. So I look here and notice this is g prime times f double prime of g times g prime. So these two are the same, so that's g prime squared, that's this. And here's my f double prime of g. So A is the answer. Good work.
So why is it an absolute value?
No, it's not absolute value. Good question. It's brackets, which mean the same thing as parentheses. Just sometimes they'll use brackets just to keep them visually separate from parentheses, but they mean exactly the same thing. So absolute value, Kristen, would have to be just a vertical bar. Good question.